Hello, and welcome back to What Is, the channel dedicated to asking fundamental questions with surprisingly complicated answers. Today, we look at the ocean's most iconic sideways traveler, the armored tank of the tide pools, the creature that looks permanently ready to give you a stern lecture. What is a crab? For most of us, the crab is just two things: a nuisance when trying to enjoy the beach, or an expensive delicacy on a ceramic platter. But the crab is so much more than its final culinary destiny. It is a biological marvel, a triumph of evolution packaged in a suit of immovable armor. The question isn't just, what is a crab? The better question is, how has a creature that can only walk crookedly managed to conquer the entire planet? Let's find out. The crustacean classification. Scientifically speaking, a crab is a decapod crustacean belonging to the infrorder Brachyura. Now, if you want to be pedantic, not everything called a crab is a true crab. Hermit crabs and king crabs, for example, are technically classified as anemorans, or false crabs. But, for today, we're focusing on the true crabs, the Brachyurans, which translates helpfully to short tail. At its most basic, a true crab is defined by a few key features. First, the legs. They are decapods, meaning they possess 10 limbs. 2 of those limbs are usually highly modified into those spectacular weapons we call claws or chalips. These aren't just handy for defense. They are used for feeding, signaling, and, occasionally, trying to play the piano. Second, the armor. Crabs are defined by their incredibly dense exoskeleton. Unlike us, who wear our skeletons internally, the crab wears its skeleton externally. This heavy, mineralized shell provides complete protection. But it comes with a major, inconvenient flaw. It doesn't stretch. And that leads us to one of the most stressful experiences in the crab's life: molting, the shell game. Growing up as an armored beast is tough. If you want to get bigger, you have to throw away your entire house. When a crab needs to grow, it absorbs seawater, causing its soft tissue to expand until it literally splits the back seam of its old shell. The crab then has to back itself out, pulling every muscle, every limb, and often its own gills, out through the opening. The entire process is equivalent to trying to escape a wetsuit that is 2 sizes too small, while simultaneously wearing a motorcycle helmet you can't remove. When it finally emerges, it is gigantic, exhausted, and terrifyingly soft. For the next few days, it is a creature made of jelly, forced to hide until its new shell hardens. This period is biologically critical, and, yes, it's also the time we harvest them to produce the rather unfortunate-sounding culinary treat known as softshell crab. Now, let's talk about the locomotion. Crabs walk sideways. Everyone knows this, but why? Is it just a flair for the dramatic? The answer is structural. A crab's leg joints are built to pivot primarily on a horizontal plane. They are optimized for lateral movement because it's the most efficient way to scurry across uneven terrain and sand while keeping their broad, flat body stable. They can move forward, but it's a slow, awkward shuffle. For speed and stability, sideways sprinting is the gold standard. It's the aquatic equivalent of moving all your furniture using the shortest path. It might look uncoordinated, but it works. The vast crab empire. If you picture a crab, you likely picture the Dungeness or the blue crab. But crabs have colonized almost every corner of the planet. Look closer, and you start to see the astonishing diversity. We have the pea crab, which is about the size of a fingernail and lives almost exclusively inside the shells of oysters and clams. It is the world's most successful and smallest live-in houseguest. On the other end of the scale, we have the Japanese spider crab, with a leg span reaching up to 12 feet. These are the arachnids of the deep. looking like something designed by H.R. Geiger after a bad night's sleep. They can live for 100 years and inhabit depths far below where the sun ever reaches. Then there are the fiddler crabs. Found in muddy mangroves, they are famous for sexual display. The male fiddler has one claw, the major claw, that is ridiculously oversized. Sometimes weighing more than half the rest of its body. It's useless for feeding, but essential for attracting a mate and fighting rivals. It's like an evolutionary arms race, where your dating success is inversely proportional to your ability to eat dinner conveniently. And the coconut crab. This terrestrial giant, the largest land arthropod in the world, uses its massive claws not just to climb trees, but to crack open coconuts. The takeaway here is clear. Whether they are delicate internal parasites, deep-sea behemoths, or armored tree climbers, crabs are tough. They are survivors. They represent the pinnacle of crustacean engineering. So, what is a crab? It is the embodiment of natural armor, an ancient creature that solved the problem of survival by wearing its shield on the outside. It is a vital, ecologic player, acting as the ocean's cleanup crew, consuming decaying matter, and serving as a critical food source for everything from fish to birds to, well, us. The crab is a decapod crustacean, defined by a hard, unyielding shell and a perpetually sidestepping gait, a gait that, paradoxically, has allowed it to walk almost anywhere. The next time you see one scuttling across the sand, take a moment to appreciate the sheer biological effort involved in moving that heavily armored body. And remember, they are always ready for battle. Just watch those claws. Thank you for joining us on this deep dive into the sideways world of the crab. If you enjoyed learning about the biology and surprising comedy of these armored scavengers, please hit that like button. And if you want more answers to the fundamental questions of the world, make sure you subscribe to What Is, and ring that notification bell so you don't miss our next episode. Let us know in the comments below, what oceanic creature should we explore next? Until then, keep asking the hard questions.